So I have maybe buffering, will go in and out, mobile phase, stationary phase, mobile phase, stationary phase. And the caffeine will go mobile phase, stationary phase, mobile phase, stationary phase, along a column. Eventually they begin to separate, So today this is what you're going to do. Today. And it shouldn't take long, it'll take like an hour. You're going to have a thin layer. And you have ibuprofen, caffeine, and you put it in a jar, acetaminophen. And in a GC apparatus, you'll have some carrier gas. If you go on to instrumental analysis, you'll have a carrier gas. It'll be larger instrument, helium, nitrogen, argon, some inert gas. Argon gas is usually used. And these gases don't show up in the detector. This is something that I did. Okay, so I found the spectrum. These are homologous series. So when I had instrumental analysis, these let's say this is ethane, what's next? Propane, butane, and this is the homologous series, the chromatograms of the homologous series. And these are common stationary phases in your text. Your stationary phase today will be paper, starch, activated carbon. Some elution orders. If you had a solution, instead of having aspirin today, before you type of aspirin, but if you had some different hydrocarbons, this is how they would elute. And these probably elute a little slower, being that they have oxygen groups and some nitrogen groups. And this is some vocabulary terms. Chromatograph. Did I say it twice? Chromatograph. Chromatography, the eluent, sample, mobile phase, retention time. You'll need to know retention time. The chromatograph is the equipment that enables the separation. The chromatograph is the physical spectrum. The eluent is the mobile phase leaving the column. And again, there are 50,000 different types of chromatography. There's liquid chromatography, GC, supercritical fluid chromatography. And the retention time. The retention time is a characteristic, again, that has to do with the polarity. The polarity of the functional groups on the molecule, the molecular weight. This you need to walk away with. And the sample is a matter being analyzed, when the sample is being treated, the analysis, the phases, the dot. Okay. The rest is referred to as waste. The solute refers to the sample components in the partition chromatography. The solute refers to any substance capable of solubilizing other substances, and especially the liquid mobile phase in liquid chromatography. So the solvent or mobile phase will probably have a polar group and a hydrocarbon group. The stationary phase is a substance which is fixed in place for the chromatography procedure, and it's usually silica. There are many different variations to a stationary phase. There are other types of chromatography, like reverse phase chromatography. You could actually get these molecules to stay or adhere in the stationary phase longer than they stay in the mobile phase. Reverse ion chromatography, there are molecules that you can add to the mobile phase. This is also something, these are also some terms that you would apply to the mobile phase, where scientists have computer calculations to see how the mobile phase. Why so much? A lot of this is used in the pharmaceutical industry, separate pharmaceuticals. And these are some terms that might go into a computer calculation of a mobile phase. The retention factor, this is something you need to walk away with today. described by the following ratio. The migration is of the substance and the solvent front, which is what you'll be measuring today. And this is the middle school experiment. We did this before, probably forgot. Okay. Remember? No? All right, this is what you do in middle school. This is your mobile phase, and you separate them. And this is the video I saw.